Greetings. Today I'm going to present this project. This project is mainly about the crypto forecasting. So, um, basically, our task is to predict the weighted average log returns of a certain asset at time t. So, how do we accomplish this task? First, we need to take a look of the target. Target is basically derived from the log return, and to eliminate the correlation between different assets, we need to do a weighted average of this return, and then we have a weighted average log returns of a certain asset. Since we are going to predict like 15 or 16 assets of all these cryptos, we need to get its data first, right? So what is our data? Our data is the basically it's just the price data. It's a k-line data, right? So we have the open, the closed, the high, low, and volume, and the VWAP, the weighted average price of a certain minute. So then we have the trade count within that bar, within that minute. So that's all the data we have. So how do we predict the return, and why do we have to predict the return instead of the price? So actually, many people have done this kind of research in stock, in cryptocurrency, and they use some complex and complicated model to predict its price, and the result, they call it extraordinary or really good in this example. So actually, we have a hypothesis in random walk. So the price would move up or down from the last price, right? So, and it has no predictable ability from the last price, because in this hypothesis it suggests that the change in this stock price are random and unpredictable. Why? Because in this hypothesis, the price t is given by this equation, this random walk equation. So we can take an expectation conditional on the last price. So it results in the last price is the best estimator of the current price. So this is why they suggest that kind of a good result when they use a really complex model, because this complex model only catch or only get the information from the last price, and the model thing is enough for the prediction. So this is how we call it a efficient market hypothesis, which means the asset price is fully reflect all available information at time t. So the best estimate for the future, or so-called we need to forecast the future's price, is today's price, or time t minus 1 price. Okay, so that's why we don't need the price to be the target. We need the return, and the price is unstable. It's not stationary. So basically, we need to develop a end-to-end ML trading pipeline if we really want to trade in real life. So in this project, we only focus on the market, like I pointed out in the figure. We only focus on the market data, and then we do some factor and feature engineering. Then we implement some models, and we do predictions. But in real practice, we still have lots of components to be done. Like in this example, we need to execute, we need to do risk management, we need to do portfolio optimized. So we have tons of work to do. So this project is only focused on this 1, 2, 3, 4, 4 components of of trading. Okay, so so this project is mainly focused about feature engineering and some model ensemble techniques. So how does feature engineering benefit us? So this project only provide us a market data like open, high, low, close, but this data in financial modeling could be limiting, since this data only capture the price movements within specific time frames, but also it miss underlying market dynamics like volatility, like the depth of the order book, something like that. Also, we sometimes need to resample the data not in time dimension but in volume dimension, because volume sometimes is a good estimator for the market dynamics. So, but in this project, based on the data given, we feature engineer some common technical analysis indicator like ATR, RSI, Bollinger Bands, and moving average MACD. This indicator to try to capture some information from the price trend, or how do this factor affect the return in the future. So it look like this. Those factors like the true range is based on the high and low price within that bar, and then we do some operation. Then we have a feature engineering code with different by myself. I make some indicator over here. So the main methodology and design is to create a cross-validation modified version of time series, because sometimes we'll leak some kind of data in financial data if we want to do the traditional k-fold cross-validation. So that's our design of this specific task. Then we use some modeling. We use some models to try capturing those information of the future prediction, future returns. First, we choose some linear models, base model for the baseline. Then we choose some boosting models, and try to figure out if the machine learning model could capture more information. Then we stack all of those machine learning model. Then we have a ensembled one to have a prediction. Lastly, we try some deep neural networks. Mainly, it's just about let's see if complicated model can capture, can reduce or capture or reduce some noise from the information. We choose LSTM for those data, and then we use some kind of ResNet design to capture some more data. And this is the evaluation metric. It's the information coefficient, and we have some result. And this is the ResNet design. So this is the result of the project, and we find out the lasso one is the best, since I think it's the most simple one and use regularization technique to reduce some kind of noise. So this complex and complicated model shows some overfitting in those noise behavior. So in the future, we think about using more L2 data, or using maybe perhaps auto feature engineering techniques for the project. Thank you.